Hey everyone, Chang here and welcome to my channel. Now, in previous video I talked about factorial, and just from memory I can recall two times where factorial played a pretty significant role. The first one is on permutation, and I went into extensive details on permutation, the formula, and the whole works. I'm going to put a link in the description down below. Then I briefly mentioned combination. And now, combination and permutation always seems to get intermingled. It's sometimes very difficult to differentiate between the two. So, I touched briefly on combination, but I didn't spend much time on it. Today, that's what I'm going to do. I want to really focus on combination, try to point out the key difference between permutation and combinations, give you the formula, and then go about solving problems, hopefully using logic, show you why the formula is great, but understanding it is a lot better. So let's look at this situation. Now this is purposely written to be very broad because I want to differentiate between the two. And I'm going to show you two different situations. So you have three colors, red, white, and blue, and you want to choose two of them. Now, if we're talking about permutation, even though I want to say the definition or the way to describe it is to find all possible combinations of them, right? Except for permutation, order actually matters. So let's look at this. We have red, white, and blue, and we're choosing two. Okay, so, and then we can use formula, but I don't want to use formula. I'm going to write it all out. So we have red, white, and then of course you can reverse it, right? Because order matters. White and red. Then you have red, blue, and then of course you have blue and red. And then afterwards you also have blue and white, which is also, you can have white and blue, right? Those are all the possible ways you can actually choose two out of these three colors. Now here's the thing though. This is permutation, meaning that we have six possibility for, let's just do P right here. Oh, well, let's be more. Permutation. I don't want to get it confused. Permutation. Okay. Now, in combination, the order doesn't actually matter. So what do I mean by that? The idea that I'm choosing two colors, it doesn't matter that I happen to choose white first and blue, or blue first and white. The end result, that result of white and blue is what I care about. So, notice that I decided to put it in this order. In permutation, we have six because we're switching it around. It's a different, basically, possibility. Whereas in combination, if you switch it around, it doesn't matter. So actually, when we're talking about combination, this whole part right here doesn't count. Because, well, we're just flipping it, right? And then the end result is still the same. It's still going to be a mixture of red and white, or red and blue, or blue and white. So rather than having six possibility, it's actually three. So this one is going to be combinations. Okay, so let's talk about the formula. Alright, so let's focus on this problem in relation to both the formula and solving it, I guess, logically or reasoning it out. If you have 8 playing cards and you choose 3, how many combinations can you get? Quite a simple problem. Now here's the thing. Normally when we're thinking about it, alright, there's 8 possible cards and we want to choose basically 3 of them. We would say 8, right? Because that's the first 8 possibility times 7, right? Because that's what you have left over. After you pick the first card out of 8 possibilities, you only have 7 left over. The second card, you have 7 possibilities. And then afterwards, you have 6 possibilities for the third card. And then you're done, right? That's normally in permutation. Now here's the thing. Remember, in combination, it's very similar except for the order of the card itself doesn't matter. So if we're talking about playing cards, regular playing card, ace, you know, all the way to King, Queen, Jack, right? If we pick one, let's just say this is King, and this is Queen, and this is Jack. You know, just for simplicity's sake. It doesn't matter that this is King, Queen, Jack, or this is Queen, King, Jack, and so on and so forth, right? That's still the same combination. So remember, combination order doesn't matter. So even though permutation, we would technically be done with this, combination, we actually have to get rid of all the, I guess you could say, different ways of reorganizing the same card, right? So in this case, if we go down here, remember they're all multiplication. So if you really think about it this way, in order to get rid of stuff in multiplication, you actually have to divide. So this is all the possibility. Let's just make it simple. Possibility of 3 cards, right? 3 cards selected. Okay, This is the possibility of the 3 cards selected out of all 8 cards. Now, at the bottom, we have to get rid of basically the different ways of organizing the cards. Organizing cards, right? So basically anything that is, I guess you could say a repeating order, the same type of cards, even if different order, right? Doesn't count. So out of 3 cards, what are the way to organize them? It's going to be 3, right? The first of them, times 2. So that's what you do. First, all the possibility of selecting 3 cards out of 8. And then within there, we want to get rid of all the possibility of reorganizing those 3 cards in different order. That's the whole point of the second one down here. And so afterwards, if you compute this, this would give you the final answer of this problem. Now, that's how we reason it out. That's how we can logically look at it. With the formula, basically is the same thing. So if you forgot what the N and R stands for, I'm just going to go over it right now. It's the same thing as in the formula for permutation. Remember, N is basically the total population. Population. Spelling is not my forte. Total population. That means total possible, I guess you could say pool. Everything you can get out of. And then R is the number of chosen or selected. Okay, so there's 4 different ways you can see basically the same, I guess you could say formula, right? So it's going to be C, which stands for combination, and then sometimes you hear this as combinatorics. That's basically combination, right? C, and then it's going to be parentheses N comma R. Now, normally when we see parentheses, we're thinking multiplication. This is not the case. This is a function. So C parentheses N comma R is just saying combination of N, which is the total population, and R is the number selected, right? Or you can see it in this weird notation kind of thing. You have parentheses and then you have the number on top and the number on bottom, which is going to be your N on top, your total population, and R is at the bottom, which is the number chosen, right? Or you can see it that's very similar to a permutation, right? You have your N, then it's going to be C instead of P right here, and then R, right? So there's just 3 different ways of writing basically the same problem. The formula itself is this right here. You're going to have N factorial, right, which is your total population factorial, divided by N minus R factorial. And we talked about this part in, like, I guess you could say permutation, because basically you only care about the 3 you chose. Everything else, it doesn't matter. And that's what the N minus R factorial does. It cancels everything out. And I'm going to go into details with this as well. And R factorial, that's the key. The R factorial is the number of chosen. And in this case, the R factorial is basically how you can reorganize those number of chosen. So let's look at this in terms of how you would solve it with a formula, right? You have N factorial, which in this case is going to be 8. We have 8 factorial, okay? Then we have our R factorial and then N minus R factorial. Now R factorial, in this case we're choosing 3, so technically it's just going to be 3 times 2 times 1. And I'm going to put it in parentheses so you can see that. That's for the R. Now the N minus R is basically 8 minus 3, which is, well, 5, right? So it's going to be 5 factorial. 5 times 4 times 3 times 2 times 1. Okay, there it is. Now that's all written out using this formula. Now here's what I want you to notice. As I talk through this, notice how similar these guys are. Well, first and foremost, we see that we have 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. So we can actually cancel them out because they're all multiplication. Boom, right there. Now look at this. This right here, right? Ignoring everything else. Try to cover it. Okay, there it is. Hopefully that works, right? We notice that we have 8, 7, 6. 8, 7, 6. And then at the bottom, 3, 2, 1. 3, 2, 1. So notice that basically this formula right here, getting rid of this, which is explained in the permutation, right? We're trying to get rid of everything else. We only want the 3 cards that are selected. And this is the different way of organizing those 3 cards. And that's where this comes in right here. So this is cool. You can go about doing this using simplification and so on and so forth. But if you logically reason it out, because you forgot this or you just find this easier, that's perfectly fine as well. Let's look at the next problem and we're going to solve it in both ways. All right, let's do this. So you have 20 different candies. You choose 4. How many different combinations can you get? Quite simple. Now, personally for me, I would just reason it out, right? 20. So the first possibility, 20. 19 left, that's my next possibility. 18 left, that's my next possibility. 17 left, that's my next possibility. That's all I care about. I'm only choosing 4. Now, what I have to do, I have to make sure that no matter what 4 I choose, the order itself doesn't matter. So I have to get rid of all the ones that are basically the same type of end result, but maybe selected in different orders. So out of 4 of them, what are different combinations I can reorganize them? Well, it's going to be 4 times 3 times 2 times 1. And just like that, that's my answer, right? Of course, you can, actually carry out the multiplication, and that's wonderful as well. But that's basically the final answer. Now, what would happen if I couldn't reason it out? Well, hopefully I could, right? Because if I can't reason it out, then I cross my finger and hope I remember the formula. Because if I can't reason it out and I don't have the formula, not great, right? But if I can reason it out and I still want to do the formula, that's fine. There's different notations. Remember, there is the C, and in this case, the total population is going to be 20, and then the chosen is 4. Or, right, there's also the way of writing, it's going to be 20, choose 4, which is the, I guess you could say parentheses with the 2 numbers on top and bottom. Or you can actually do this as well. It's going to be 20, a small 20, C, and then 4, whatever you choose, right? Basically, formula, same thing. Total population, 20 factorial over, right, the whatever's left over, because guess what? I only want 4 of them, so technically it's going to be 20 minus 4 factorial, and I got to figure out, the different ways of organizing the 4, so I have to make sure I have 4 factorial here. Now, a way to actually memorize this, if you really want to, is just notice this. Total population, and in the bottom, total population and the chosen, what you're going to do is you're always going to get the total population and you minus the chosen. After that, you just got to remember what the chosen is, and then whatever you minus, just make sure you put it on the outside. That's one way to remember it, right? So basically, this is it. 20 factorial over 20 minus 4 factorial and 4 factorial. So it's just basically 20 factorial, 16 factorial, 4 factorial. So if this makes you I feel a little better on memorizing, just remember that these two add together has to be, the total population kind of thing. Not actually adding, but just think about the numbers itself. Like 16 plus 4 equals 20, right? Don't actually add, you're going to make a mistake, right? And don't quote me on that and be like, he said that. No. Okay, so here we are. So we have 20 factorial over 16 factorial over 4 times 4 factorial. So in that case, that's just basically 20 times 19 times 18 times 17 times blah, 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 all the way to 1. Okay, at the bottom, we have 16 times 15 times 14 times blah, 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 all the way to the bottom right here, all the way to 1. And then we also have the whole 4 times 3 times 2 times 1. I didn't want to do blah, 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 because, there's only 4 numbers, and I don't want to be that lazy. So, all multiplication, great. Even though I stop here, this is technically 16, 15, 14 all the way to 1, right? Here's 16, 15, 14 all the way to 1. So basically, I can just cancel out this whole thing right here and this whole thing right here. So what I have left over is 20 times 19 times 18 times 17 over 4 times 3 times 2 times 1. Ta-da, right? So basically, it's still technically the same thing. So we have this guy right here and this guy right here, which is the same as that one on top and that one on bottom. So formula, reasoning, both way works. Pick your poison. Alright, so now that we've reached the end of this video, now I understand it's a sort of a shorter video, but I'm hoping that this clarifies the difference between combination and permutation a little more. Once again, permutation, order actually matters. So whether something comes first versus it coming out second, right, and switching the order, those are different results. Those count for entirely different things. Whereas combination, they don't, right? Like as in the first example, it doesn't matter if you chose red first then white or white first then red. The end result is you still have red and white, and that's what really counts. There's 2 ways to go about it, or at least that I'm comfortable with. The first one is always the one that I prefer, is just logically reason it out, right? Rather than spend time trying to remember the formula, I think that always makes a little more sense to me. So we can always remember that out of the total population, you're choosing whatever you're choosing, right? And then you're just putting the total possibility on top. But the key is that at the bottom, you also have to include, because, well, they're all multiplication, so at the bottom, you have to do division. All the possible ways of organizing what you have chosen. Because remember, in combinations, order doesn't matter. And so we're getting rid of all those. It has a formula. Once again, 3 different notations. You have the one where it's a C as a function, or you have the parentheses with the number on top, number bottom, or you have the one that looks like what your C in like permutation, except for instead of a P, it's a C. All means the same thing. Formula is very similar to permutation, except for you have to add that extra section of, you know, basically reorganizing all the ones that you've chosen. Now, there could be more complicated problems than what I've shown you. Especially, notice this. The key difference, I said there's 20 different candies. Of course, if there's, you know, 20 candies and some of them are repeating, it gets more complicated. But hopefully, this clarifies the actual concept. Thank you for watching this video. And, you know, go out there, be a boss, understand exactly the difference between combinations and permutation. Don't be like I did, where I'm just interswitching words and people are looking at me like, hmm? Right? Thank you for watching this video. See you in the next one.